Breathing biology. Your lungs are like two washing up sponges. Yeah, well, they've got lots of holes that are full of air. Each lung has 300 million little holes called alveoli. Alveoli is how to say alveoli. Little E there. When you breathe in, your alveoli fill with air. Air is 20% oxygen. The oxygen molecules are going 1,000 miles per hour. Well, not all of them. Some of them go a bit more, some of them going a bit less, but on average, they're going 1,000 miles an hour. The oxygen molecules hit the cells of the alveoli and go through to the blood capillaries. Capillaries. This is called diffusion. Diffusion. When in the blood capillaries, the oxygen diffuses into red blood cells. Diffuses. Then the oxygen combines with the red blood cells' hemoglobin. Hemoglobin. Hemoglobin with oxygen is called oxyhemoglobin. Oxygen is carried in the red blood cells' hemoglobin, and carbon dioxide globin, and carbon dioxide is carried in the blood's orange liquid called plasma. Plasma. Yeah, like 60% of your blood is plasma. That's why when you give blood, sometimes your blood is spun in a centrifuge. So the red blood cells go to the bottom and the plasma is at the top. You can separate them, and the plasma can be put into anybody to save their lives. Particularly if you don't know what blood group you are. It's for people giving blood. Plasma is always good. The carbon dioxide diffuses from the thin capillary blood tubes into the alveoli. Oh yeah, and the carbon dioxide gets out. Oxygen gets in via the alveoli, diffusion, and the movement diffusion of molecules gets oxygen into the bloodstream via the alveoli, and carbon dioxide gets out. So you breathe out 16% oxygen and 4% carbon dioxide. Draw an alveoli and capillary to illustrate the oxygen and CO2 diffusing. Okay, so alveoli is like it's a bubble of the red blood cells. In red blood cells are sort of donut shapes, with the hole in the donut not quite pushed through. So capillary, red blood cell, deoxygenated, and these ones here, oxygenated, red blood cell. Where do they get the oxygen from? Well, hey, O2 diffuses, and the CO2 diffuses out of the plasma. O2. The plasma is the liquid liquid between the cells that the cells go whooshing around in. Breathing normally in and out is your tidal volume. Yeah, just like the sea tides. The sea tides go up and down every 12 hours, 25 minutes. A deep breath volume, you breathe in and out like 10 times a minute. Sometimes more if you're running. A deep breath volume is your vital capacity. For adults, vital capacity is between 3 litres and 5 litres. Yes, that's like 3 big cartons of milk, 5 big cartons of milk. That's how much you breathe in and out when you're an adult and breathing your biggest breath. To breathe in, the muscles under your lungs contract downwards, increasing the volume of the lungs. This muscle is the diaphragm. Oh, diaphragm. Okay. The intercostal muscles between the ribs contract. The contraction of the intercostal muscles pulls the ribs out and up, increasing the volume of your lungs. Yes, if you put your hand on your ribs, you can breathe by moving your ribs. Or if you put your hand in your stomach, you can breathe by making your stomach go out, which is your diaphragm going down underneath your lungs. There's two different ways of breathing. Singers particularly breathe using their diaphragm. So if you watch a singer, or if you put your hand on your chest and you are a singer, then your ribs don't move. It's all done in the diaphragm. The increased volume decreases the air pressure. The air is pushed into your lungs by the squashing pressure of the 10 miles of air above your head. Air coming in is inhalation. Inhale. Inhalation. When you breathe out, the intercostal muscles relax and gravity pulls your ribs down. This squashes the air into a small volume, increasing the pressure. The increased pressure pushes the air out. Now, pushing the air out. The diaphragm also relaxes and springs back up, squashing the lungs to an even smaller volume. The secondary use of the ribs is to protect the lungs. Yes, they're bones. It's like a suit of armour to protect your lungs. Draw a lung, some ribs, and a diaphragm to illustrate inhalation. Okay. Right, let's have the band standing up. Inhalation. So that's the diaphragm goes down. Diaphragm. Okay, that's the diaphragm that goes down. The ribs. So the muscle contracts, making the ribs come together. All the muscles contract between your ribs. And there's your lungs. And now there's your lungs. The ribs have gone up and out. Yep, and they're shorter altogether. Cool. Ribs, lungs, intercostal muscles. Whoa. Oh, there you go. Not my best diagram, but it's pretty good. Cool. Press my picture to get more of my videos. Press like, press subscribe. Bye.